Okay, so we'll proceed in unprecedented sum series to integral calculus. Sum series to integral calculus, this is something that we have invented and it is not available in any of the book. Anyone can try. And what is the summation that we are trying for the past 3 days is 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8 and so on. This is the discussion that we are pursuing. Okay. In that manner, many ways we have already seen. Three ways to solve this problem. We have already seen through successive approximation, where we are segregating the odd number and even number. Odd numbers are in positive and even numbers are in negative. Means we are deliberately we are segregating it, separating it. This is what we are doing. In examination, a student is seeing there is a question called 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8 plus 33. How much it is? Okay. Someone would say, I am going to calculate it manually. Then it will be difficult. So what to do in that manner? Then what we thought about it? Let's consider there is no negative. There is only positive. In that manner, what we are trying to say is, okay, this is x-axis and this is y-axis. This is x-axis, this is y-axis. In that manner, I have this as origin. This is x-axis, this is y-axis, this is origin. And now we have x equal to 1, 2, 3, 4, 5, 6, 7, 8. Where the actual is when x equal to 1, then function over x is 1 because in examination it is written as 1. When x equal to 2, then function over x is minus 2. When x equal to 3, then function over x is 3. When x equal to 4, then function over x is minus 4. Like so. Okay, I'm saying consider everything positive. Means x equal to 1, then it is 1. X equal to 2, then it is 2. X equal to 3, then it is 3. X equal to 4, then it is 4. And so on. Consider a function like this, but concept is actually the even numbers are negative. In that manner, can we calculate the net summation separately for even number separately for odd number separate? That is the arena that we have already talked about. Okay, how to calculate the odd number separately? We have already talked to calculate the odd number separately. What is the formula of fx? I mean, if I segregate odd number, that is 1, at x equal to 1, I have 1. When x equal to 3, I have 3. When x equal to 5, I have 5. When x equal to 7, I have 7. X equal to 9, I have 9. So I can say that it looks like if I break this into n part, where x equal to n, we have n, where n is odd number. If I divide into n part, then I can write on a paper 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 and so on. Okay, then someone would say, why don't you write x? Summation x equal to 1 to n function over x. Function over x plus function over x plus function over x plus function over x plus function over x. In that manner, first function over x is at x equal to 1, x equal to 3, x equal to 5, x equal to 7. Okay, this is what it is. Means sigma summation x equal to 1 to n function over x. X is sampled at odd number only, but function over x is x1, x. Okay, if function over x is x, then how we can compute through integral calculus? Many times we have talked about it. How to convert a discrete function into integral function. I have a fx as discrete function and that is x. When x equal to 1, I have a vertical of 1. When x equal to 3, I have a vertical of 3. When x equal to 5, I have a vertical of 5. If someone connects all the top point, if someone connects all the top point, then it will draw a straight line. It will draw a straight line. And this is consider this is a straight line. And this is function over x. If this is function over x, equation of this straight line is x and it is sampled at x equal to 1, 3, 5, 7, 9 and so on. Okay, this is the concept. This is the concept. Okay, if that is the arena, if that is the arena of discussion, if that is the concept, then what is function over x? Function over x is x. Okay. Now this is a, if I talk about this straight, this is x-axis, this is x-axis, and this is being a straight line. If this is x-axis, this is being a straight line. If this is a straight line, then equation of this straight line is x. Okay, and this is sample at x equal to 1, 3, 5, 7. Now someone would say, what do you mean? What I mean is, if this is x-axis, then there are vertical. At x equal to 1, vertical is 1. When x equal to 3, vertical is 3. X equal to 5, vertical is 5. X equal to 7, vertical is 7. Means addition of all the vertical is the target. Summation x equal to 1 to n. Function over x. Summation x equal to 1 to n, function over x, where function over x is can be written as function over x at x equal to 1, function over x at x equal to 3, function over x at x equal to 5, function over x at x equal to 7, and so on. There are vertical that we are computing. If I'm talking about fx equal to x, then fx equal to x, if this is x-axis, then that is a, if I connect all the top points, then it will make a line that is a discrete function where it is sampled at different points. Can we think about a continuous function called gx? This is a continuous function and this is completely continuous. In that manner, what I'm trying to achieve when fx is 1, x equal to 1, then I have a height of 1. When x equal to 3, I have height of 3. This is separate, gx. At x equal to 1 and x equal to 3, I have a one width. And this area strip, if I take like this, it will go and hit gx. What I'm trying to say, if I have n number of verticals, then there are n number of area strip. One area strip is from x equal to 1 to 3, 3 to 5, and last one will be n to n plus 2. This is what we are saying. So we can say that fx at x equal to 1 is same as gx dx, area of gx dx between x equal to 1 and 3. What are you talking? I'm talking if I take fx at x equal to x, if there is any x equal to x, then fx, this is fx at x equal to x, whatever it is, that will be same as x to x plus 2, because jump of 2 is there. X to x plus 2, gx dx. Okay, we have already seen this. Then fx equal to x plus 2 gx dx, and we found that this will satisfy when fx is x. This will satisfy if gx is x by 2 minus 1 by 2. We'll try. X by 2 integration is x square by 2, x square by 4, x to x plus 2, x square plus 4x plus 4 minus x square, x is 4, that will come as 4x plus 4 by 4, x plus 1, minus 1 by 2 integration is minus 1 by 2x, x plus 2 minus x, 2 by 2, 1 minus 1, x plus 1 minus 1x. So we know if gx is x by 2 minus 1 by 2, if gx is x by 2 minus 1 by 2, then integration from x to x plus 2 will result in x, that is fx. Means for each fx, right hand side, if I take area strip in continuous function gx, they will be same. What do you mean? I mean the net summation of all the vertical will be area under the gx, and that is from 1 to n plus 2, because n to n plus 2 is the nth sub area. Okay, what is the summation of integration? What is summation of odd number? The summation of odd number is x equal to 1 to n plus 2 x square gx dx x square by 2 minus 1 by 2 x 1 by 2 2 x dx is x by 2 minus 1 by 2. Net will come 1 to n plus 2. Net will come as n into, I'm sorry, n plus 1 by 2 whole square, or n square plus 2n plus 1 by 4. By 4. This is what the summation is. Let's talk in the previous video. Now if I take n, then n is odd number. Let's talk about summing all the even number. Even number starts at 2, 4, 6. At x equal to 2, it is 2. X equal to 4, it is 4. X equal to 6, it is 6. Someone will say actually it is negative. You are taking positive. We will add positive and then we will take minus outside. Then it will become negative. Okay. Now the question is arising here, also gap of 2 is there. So same fundamental will work to calculate the gx for this. Main idea is to calculate gx against it. So what will be gx against it? Now in the previous video, that's why we are making this video. Okay, we are doing this session. If I take, now at the end I have to merge both number. At the end I have to merge whatever even number we did minus, whatever odd number we calculated, the summation, that is n plus 1 by 2 whole square, and then I have to subtract what even number summation we are doing. Then it will come as 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8. 1 plus 3 plus 5 plus 7 plus 9 we are computing first, that is n plus 1 by 2 whole square. Then we will compute 2 plus 4 plus 6 plus 8 as n only, and then we will subtract, then we will get the result. But caveat here is, what is n? N should be same in both cases, then only we can merge it. So the last day, okay, previous day, we took n as a reference in odd number, and accordingly we calculated the summation of even number thinking n is odd. Then we took limit of the calculation, fx is same, x by 2 minus 1 by 2. But if I am calculating the full summation of series, consider in this fashion. Consider it is 1, 3, 5, 7, n. Then I am calculating 2 plus 4 plus 6 plus n minus 1. I take n as even only. Reference point is, I take n as odd only. The reference point of n is odd only. In that manner, I go minus 1, n minus 1. Then this is even number. So if I go with the net integration to calculate summation of all the even number, then it will start from 2 and it will go up to n minus 1 plus 2 to jump from n minus 1, where n is odd number. Then we can merge. N must be same at both places. Okay, this is the concept that we pursued. I remember it came as n square minus 1 by 2, n square minus 1 by 4. Now I can settle down both n square plus 2n plus 1 by 4 minus n square minus 1 by 4. N square gone. 2n plus 2 by 4, that came as n plus 1 by 2. That is the solution. Anyway, now someone would say, can we go independently? Why we are doing a churning? Why doing a churning? So that this new invention should be, first of all, it will be proven through all the possible ways, and second thing, there will be a lot of example to consider. We have taken example of 1 by 2, sampling in 1 by 2, sampling in 1, and first time we are taking sampling in 2, x, then x plus 2, then x plus 4, and so on. Okay, so let's take that we go independently. If I am trying to calculate addition of n number in odd numbers, then we get n into n plus 1 by 2 whole square. n plus 1 by 2 complete whole square. This is what we are going as far as odd number is concerned. What about even number? Now let's take 2 plus 4 plus 6 plus 8 plus 10 n, and both n are different now. In odd number n is odd. If I take even number, then n is even. Both are separate. That's why this discussion is separate. Okay, from the previous discussion. Now n is even number. They have independent n on that side and this side. Then how I can proceed on this independence? That is the question mark. If that is the question mark, we will try. Now we have gx as x by 2 minus 1 by 2. If I do integration, it will come from 2 to n plus 2, because we have taken n number of sub area and each sub area belongs to one vertical. What I'm trying to say, when x equal to 2, there is a vertical called 2, and this vertical will be exactly same as area between x equal to 2 and x equal to 4, and will meet gx. I'm trying to say fx plus fx plus fx plus fx plus fx up to n term, that is fx at x equal to 2, fx at x equal to 4, fx at x equal to 6, plus fx at x equal to n. That is same as 2 to 4 gx dx plus 4 to 6 gx dx plus 6 to 8 gx dx plus n to n plus 2 gx dx, because n sub area will come, same number of sub area will come, the number we have this side in sigma, digit discrete to continuous. In that manner, if I say I have summation x equal to 2 to n fx, then it will be equal to limit 2 to n plus 2 gx dx. Okay, then what will be the summation now? What will be the integration now? Gx is x by 2 minus 1 by 2. X by 2 will become x square by 4. Now it is n plus 2, n plus 2 whole square minus 2 square. Okay, first we will settle it down. That will become n square plus 4n plus 4 minus 4. 4 gone. Okay, 4 gone. It becomes n square plus 4n. Makes sense? N square plus 4n. That's by 4. Minus 1 by 2. N plus 2 minus 2. Only n. Okay, it becomes minus n by 2. Alright. If I take 4 as denominator, then it will become n square plus 4n minus n will become 2n by 4. N square plus 2n by 4. This is the solution. N square plus 2n by 4. What do you mean? Let's take n equal to 2. 2 to the power 2 is 4. 4 plus 4 is 8. 8 by 4 is 2. Perfect. Let's take n equal to 10. Earlier we were taking n in odd number only, and 1 we were subtracting. Earlier we calculated summation of even number as n square minus 1 by 2, where n is odd number. If I want to calculate the summation of all the even number up to 8, then I have to take n1 ahead, that is 9. Means up to 8 is n is 9. 9 square minus 1, that will come as 80 by 4, 20. Up to 8 summation is 20, but now I can take n as 8 only. Then it will be n square plus 2n by 4. 8, 64 plus 16, 81. Same. But now both are independent now. Both are independent. Now, if I calculate addition of odd numbers, then it becomes n plus 1 whole square by 4, or n plus 1 by 2 complete whole square. If I take addition of even number, then it becomes n square plus 2n by 4. Can I subtract both? Because the actual summation is 1 minus 2 plus 3 minus 4 plus 5 minus 5, 6 plus 7 minus 8 plus 9 minus 10, and so on. Okay, that is the actual one up to 33. In that manner, I have actually 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 up to 33, minus, and in bracket 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus up to 32. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 33 minus, and in bracket 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus whatsoever up to end. These are the two terms that we have to calculate. Can we go now? Anyone would think, oh, it's very simple. Calculation of all the odd number you got n plus 1 by 2 whole square, right? And then calculation of even number you got n square plus 2n by 4, right? Subtract it. Result will come, but result will never come. Why not come? Because n we have taken here as odd number and n we have taken here as even number. So then what we can do? What you want? I want up to 33. If you want up to 33, then n in even number will be 1. N in whatever n we have taken in even number, we have to go one more. N, if I take up to, if I place n equal to 32, I'm sorry, if I place n equal to if I place n equal to 32, I'll get summation up to 32. That is true. But I have to place the number. If I take in term of n only, then even number is less than odd number. I am trying to calculate up to 33, where maximum number is 33 and that is odd. Even number is 32 and that is less than minus 32. That is less than the odd number. Means I have to subtract 1. I have to subtract, hope we'll try. I have to, if I take n plus 1 whole square by 2 whole square by 4 minus, then if I try to calculate something, here n belongs to 32. N should be same in both cases. N should be same as both cases. Can we try this as n instead of n? Can we write it as n plus 1? Can we write it as n plus 1? Then we can try that both will be same, or we'll try n minus 1. Okay, concept is that n should be merged with each other, then only we can go summation of odd number minus summation of even number. Okay, that is the concept. Let's try now. N square plus 2n by 4, what we are getting? N square plus 2n by 4. If I add 1, okay, if I add 1, then what we will get? N square plus 2n plus 1 plus 2n plus 2. Certainly this is not, we will get the solution, where we will take the n as okay, let's try n minus 1. N minus 1 whole square will become n square minus 2n plus 1 plus 2n. N will become n minus 1, 2n minus 2. N square minus 2n plus 1 plus 2n minus 2. Net will be n square minus 1. This is exactly what we had got previous day. What I am trying to do, it is must be understood now. We have summation of two numbers. One number is odd number, that is n plus 1 by 2 whole square, where n is odd, Now here I am saying the summation of all the even number is n square plus 2n by 4, where n is even. If n is even, and n, if I see the question in the examination, 1 minus 2 plus 3 minus 4 plus 5 up to 33, then n in the even number is 1 less than n in odd number. If I say n is 33, then n in this even number calculation is 1 minus. I believe it is understandable. If this is addition of all the odd numbers, that is n plus 1 by 2 complete whole square, minus then addition of all the even numbers. But here n, this n should be 1 less than this n. Then only they will match and we can merge, because we are calculating even number up to 32 only. In that manner, wherever I see n here, n square plus 2n, instead of n, I have to replace it by n minus 1. That n is this odd number n. From there, this n is 1 less. So I'll subtract now. So So instead of n, I'll write n minus 1. So n square will become n minus 1 whole square. Plus 2n will become 2n minus 1, where n is odd number. So this is 1 less than that. Okay, then how much it will become? N square minus 2n plus 1 plus 2n minus 2. N square minus 1 by 2. Now we can settle down. Now both n are same, that is odd number. Now n square plus 2n plus 1 by 4 minus n square minus 1 by 4. That will come n square plus 2n plus 1 minus n square plus 1. I think it is alright. N square plus 2n plus 1, and this is n square minus 1. If I say minus, then it will become minus n square plus 1. N square will go away. 2n plus 1, this is also plus 1. 2n plus 2 by 4. N plus 1 by 2 is the answer, where n is odd number. Then it will come as 33 plus 1 by 2. Answer is 17, and that is actually correct. That is actually correct. Now someone would say, can you settle down in reverse manner? Can you settle down in reverse manner? What do you mean? Reverse manner means take n as even number. Take n as even number. If I take n as even number, then this is all right. That is n square plus 2n by 4. Because n is even number. Then I have to make here n as n plus 1. Now there are two sides. One is n in odd number, n in even number. Which reference we are taking? If I take even number n as reference, then this n will be one more. If I take this n as reference, then this n will be one less, because it is up to 32 only, even number. So here we have n plus 1 whole square. Now n will be n plus 1 again. So n plus 2, where this n is reference. N plus 2 whole square by 4. N square plus 4n plus n square plus 4n plus 4 by 4 minus n square plus 2n by 4. If I settle down, n square will go away. 4n plus 4 minus 2n. I think so. I don't know. Okay, 2n plus 4 by 4 is the answer. 2n plus 4 by 4. N plus 2 by 2. This is the answer. What is n? In summation up to 33, n is 32, one less. Okay. N, what I said, I forgot. N plus 2 by 2. N is 32. 32 plus 2 by 2. 17, one. Exactly same. Now in examination, next question is 1 minus 2 plus 3 minus 4 up to 33, not 33, up to minus 34 is the question. Next question is 1 minus 2 plus 3 minus 4 plus 5 up to minus 34 or minus 54. End is even number. Then how we can calculate? Again, we will try in same manner we did. If I go n as a even number, then this formula what we deduce is perfect. What is the formula? Is n plus 2 by 2. N plus 2 by 2. Okay, n plus 2 by 2. That should be the result. I think so. N plus 2. What is n? What is n? This I'm sorry. So we'll try again. Now we have this n is reference. This n is reference. If this n is reference, then I have odd number n is 1 less than this. Next. Now minus 34 is bigger than 33.